So hi, my name is Mark Borstein. I am the CTO at Tremolo Security, and I'm going to be talking to you about cloud native in public safety systems. So like I said, CTO at Tremolo Security, I've got 20 plus years in identity management experience across federal agencies, commercial companies, products, etc. I have been working in the Kubernetes world since 2015, 2016. If you have ever read the OpenID Connect documentation and cussed at it, I'm sorry. I am also the co-author of Kubernetes and Enterprise Guide, 2nd edition. Got raffle for 5 free books over at the table if you want to stop by. And then if you don't get a free book, we got a 20% discount code for folks that want to order it on Amazon. And like I said, lots of contributions to projects. Wrote the code for the dashboard, Kubernetes dashboard to support impersonation. Same thing for Kiali. And you'll always find me in the Kubernetes site. Can I lower the volume on this? Just a lot of feedback.
People still hear me? Yeah. For the recording, I think for the recording, yeah.
No, I was just thinking if one of the mics was hot.
Test? Okay, cool. Okay, so enough about me. So what is the NTR IAMS program? IAMS stands for Identity and Access Management. Yes, I am available for your marketing needs. It was started in 2013, or it was actually started in 2011. Excuse me. It's an identity as a service for 22 plus jurisdictions here in the DC area. Also integrates the Commonwealth of Virginia, State of Maryland, and US federal agencies. It does both authentication and authorization, which is pretty unique for IDaaSs. A lot of centralized authentication systems are just identity brokers, whereas we offer a workflow-based authorization solution. So users are able to log into the system, request access for things, get it approved, recertification, all that good stuff. And our applications span from emergency response systems that have to be available 24/7 to content management systems, SharePoint sites, etc. We've been live since 2013, and everything is built on top of Open Unison from my company, Tremolo Security. So if you might have heard of us in the Kubernetes world for providing access to clusters, we also have a full identity solution that's powerless. So IAMS began on September 11, 2001, when terrorists flew an airplane into the Pentagon. Fire units, rescue units, first responders from all over the area came to help, and it was quickly realized that there was a communications problem. Radios didn't work with each other. There was no way for people to communicate across jurisdictions. And so FEMA created this grant called UASI that funded billions of dollars of public safety systems. And one of the safety systems that was funded was this idea called the NCR net, a network that could survive another 9/11 style attack without, even if the commercial backbone of the internet broke. Now, 2022, that's a little bit different, but at the time, that was a real concern. So this network got stood up, and nobody wanted to put their applications on because they didn't want to have yet another username and password. So Tremolo got brought in 2011 to do a proof of concept. 5 jurisdictions with a single SharePoint site, no cross-force trusts. It went beautifully. And we went live in 2013. So when we talk about public safety systems, our priorities are a little bit different than a lot of other systems. Our first requirement is availability. A lot of these systems, they just have to be there. it has to be dial tone, right? The authentication cannot be a problem. You don't want somebody to die because the fire units didn't get coordinated in time. Next up is privacy. The stuff that is not public information, a lot of it's actually public information as long as you have the right radio, but the stuff that's not public information is very closely guarded private health information, or things like mug shots, things that are very important that should not be out there. And so we need to make sure that we're keeping our privacy regulations in place. Then security, extremely important, don't get me wrong. But again, a lot of the information isn't always private information, and so we need to make sure to balance the security with the mission. And then finally, performance. A lot of times in the Kubernetes world, we're talking about hyperscale and millions of transactions a second. And in the public safety world, you just don't have that. You might have a few hundred users using the system, but that system has to be available. So some of the challenges we've had in building the system in a cloud-native way. Lots of legacy systems. In cloud-native, we say if it ain't broke, don't fix it is like the worst thing in the world. In the public safety world, if it ain't broke, don't fix it is still kind of gospel. That's been changing, but in a very risk-adverse area, you've got a lot of things that are really, really old because they still work. Siloing is a big deal. We're used to sharing APIs, sharing specs, making things work together. Whereas in the public safety world, everything is siloed. The public safety systems inside the local jurisdictions are siloed off from the local government, and then the fire is siloed off from the police, and the different parts of the police are siloed off from other police. So there's a lot of different areas that you have to manage. That becomes very difficult when translating that into the technology. Those two things lead to a lot of technical challenges because, in the cloud-native world, we're so often saying, okay, just give me the API to do it. Well, yeah, this thing's running on a mainframe that doesn't have a connection to an API. And so that combination leads to a real issue with the technology integration. Lots of Windows. Not that Windows in and of itself is a problem, but you're dealing with a lot of Windows development paradigms that are just not heavy API-centric. That's changed over the years, but not all the systems have changed with it. And then finally, regulations. Very highly regulated, public health information, personally identifiable information. All these things are very important, and no card-carrying member of the ACLU cares more about it than me when I'm looking at this stuff. So we've been in production now for almost 10 years, and we've had quite a long road to get to Kubernetes. So we started off using virtual appliances. Those were all the rage, all the cool kids had them. And I mean, it worked okay, but they were VMs. We ran into a lot of issues around trying to deploy something that was an appliance into an environment where there were certain assumptions. So like, the first thing we were asked to do was add support for SNMP to our appliance. And so we're like, no, we don't want to do that. And that just created an amazing storm. It was also a mix of Windows and Linux. There was an assumption at the time that the system would eventually transition to county personnel, and that just never really materialized. So we ran that way for a few years and a couple of data centers, and then on our third data center move, we said, okay, we're going to get rid of Windows. We're going to switch everything over to Linux. We're going to switch everything over to open source technology. So we got rid of SQL Server and we moved to MariaDB, running Percona as the synchronization engine. And that worked fine. It was great. And this was 2015, and this thing called Docker was really getting a lot of steam. And we said, okay, let's see if we can do this using Docker containers. and it was a spectacular failure. We made the cardinal mistake of treating our containers like VMs, just smaller. At the time, Unison's management was very old school enterprisey with a GUI, and that GUI managed a configuration that would get synced out, and it worked okay with VMs. It worked decently well with VMs, but Docker containers, it didn't work at all. So we realized how bad of a failure it was and said, okay, this Kubernetes thing sounds kind of interesting. I think it'll do what we really want, but we're not in a position to deploy it. So a few years later, we end up moving to a public cloud, and at that point we said, okay, let's go to Kubernetes. But as most things in this city run, everything was based on contracts, and we only had a few weeks to be able to move into the new environment before the contract ran out. So with that deadline, we said, okay, you know what, we're just going to go with Ansible. We're going to simplify the environment, but we're not going to go to Kubernetes quite yet. And then finally, we managed to get to Kubernetes. So going from virtual appliances to Ansible was our first big automation change. It was the first time that we really went from a what I would call an old school or legacy enterprise approach of manually patching, relying on the product to synchronize things rather than relying on the infrastructure, external monitoring. We wanted to bring that all in-house. So we did a few things. The first was we switched from it's funny to call my own product a legacy system, but from the legacy commercial Unison to the open source open Unison. And the biggest part of that was we stopped with GUIs. We just abandoned the GUI altogether. And we stopped relying on ourselves to do the synchronization of configuration and said, you know what, we're going to rely on infrastructure to do that. And that was a big help because now we didn't have one less thing to lock down, one less thing to manage, and quite frankly, it increased our velocity because now that was a lot easier to develop without having to add everything into a GUI. We also externalized our configuration, so the package that would get deployed, very simple text replacement, but it made it so that we could develop locally, deploy to a dev environment, deploy the same binary to a production environment, all without having to redo the configuration every time. And we sort of emulated containers with Ansible. We had Ansible playbooks that would, we could give it an empty VM and it would generate a full stack in a run. We stored secrets in Amazon Param Store. We stored the binaries themselves and locked down S3 buckets. And it worked great. I mean, we had playbooks that every week we ran our patches, and it worked. Whenever we had a new release, we were able to push it out pretty easily. The biggest change, really from an operations standpoint, also came from monitoring. Prior to this move, we were relying on a very popular commercial monitoring system that we had no control over. And so we said, no, we don't like that. It's not monitoring what we want. We're getting tons of false positive alerts. We want to move to a cloud-native monitoring solution. The problem was that we didn't have any place to run it inside the environment. So we said, all right, we at Tremolo, we're going to run the monitoring system. But how do I run a Prometheus scrape against a bunch of servers securely from our cloud to the customer's cloud? So we came up with this approach. In our cloud, we had an open Unison that ran. Prometheus would hit the monitoring endpoint on that open Unison. Open Unison puts a message on an SQS bus. Inside of the IAMS network, another open Unison picks it up off the bus, scrapes all the servers, condenses everything down, puts it back on the bus, goes back to the open Unison in the cloud. So that way we were able to scrape everything, but we have no ingress into the environment. So there's no way that you could get into the environment through there. That worked really well. Now, availability is a big deal, so how do we make sure that that open unison didn't go down? So we had alerting set up there. How do we make sure that that alerting didn't go down? We relied on Amazon's Route 53 to do pings. So we had 3 levels of monitoring, all running synthetic transactions. So that way we knew the system was up and running. And when we got an alert, it was a real alert. So that worked well for about a year. We had that running and said, okay, we're moving to Kubernetes. Let's make the jump. So the first big challenge we had was networking. The NCRNet is a private network. And so we have applications that are both on the public internet and on this private network. So how do we support both? Legacy security, spreadsheets of IPs and for firewalls. You know, these IPs are now all dynamic. How are we going to handle that? That one actually turned out not to be as big of a deal as I thought it was going to be. CI/CD was the big one. So we wanted to move from a manual process of running playbooks to do patches to getting to the point where when things were patched, we just pushed out new stuff, as opposed to the let's do this at a regular cadence. Logging was another big one. We had built a custom solution for aggregating all the logs into a relational database. There was no budget for Splunk. And that batch process wasn't going to work real well in Kubernetes because we didn't want to have to store those logs somewhere. And then monitoring, that great monitoring system we had built before, we wanted to get rid of that. So, actually let's talk about logging here for a second. So the way that we solved the logging issue was we were already using a message bus inside the system. So every time somebody makes a request to access something, every task in that workflow goes on a message bus. So we said, okay, that's a high performance message bus. Going back to what I said about performance, you know, availability is more important than performance. We don't have millions of hits a day. You know, we have about, I just ran these numbers, I want to say we have about 7,000 or 8,000 users. Every day we might get 500 or 600. So it's not super high volume. You know, we're not worried about hyperscale. So we built a solution where we said, okay, we're gonna, every time we log a request, we use Log4j internally. Yes, we're patched. The request, the text-based request would still go to the text logs, but then we built a custom logger that would actually put that log on the bus, and then something else would process it in near real time. So we actually got better capabilities out of the deal, so we weren't doing batch processing of it anymore. That worked really well. And then monitoring, instead of doing that big setup where Tremolo's doing the monitoring, we're actually able to make most of it go inside of the cloud now. So we run our own Prometheus, we run our own alert manager, we run our own Grafana. We still run our Prometheus at Tremolo's cloud. The main difference, though, is that Prometheus is responsible just for running synthetic transactions through the system every 30 seconds, I think, to make sure that the system's alive and working and doing what it's supposed to do. So it vastly simplified, like that whole SQS thing went away. So the next big task was CI/CD. How are we going to keep these containers up to date? So at Tremolo Security, we already monitor the CVEs in our containers. So every night we have a batch process that goes through all the containers that we publish in the Tremolo Security repo on Docker Hub and looks to see if Canonical has patched any of the open CVEs. And if it has, that kicks off a process to rebuild them. So we already had that in place, so we're going to piggyback off of that. So then what we said was, okay, now whenever the Open Unison base container gets rebuilt, let's go ahead and rebuild the IAMS Open Unison containers. So what we would do is the CI/CD system that we're using for IAMS looks to the GitHub repo and for changes to GitHub. So we ran a git patch basically onto a patch log, and that update would automatically trigger the CI/CD system to do a rebuild. CI/CD system would rebuild, push into our private registry, and then we would know it's working because we have the same monitoring in our dev environment that we have in our prod environment. So all we gotta do is fire up the dev environment. The dev environment does not stay up 24/7. We only use it when we need it. So we fire up the dev environment, let it run for a few minutes just to make sure that everything's still kosher. We know that it is, great. We can go ahead and schedule a push to prod. This works really well because things just get done quickly, and it also gives us the ability to short circuit. So I mentioned Log4j. We are a Java-based system. 7:30 in the morning, I start looking at Twitter going, oh, this is bad. Really, really bad. I go to my wife, I say, you need to take the kids into school today. I think I need to focus on this for a bit. We were updated by 9:30. We had the latest version of Log4j up. We manage another system inside of Fairfax County that was about the same time, so we were tackling both. But we were able to short circuit pretty quickly because, you know, we at Tremolo decided that we weren't going to cut a new release for the Log4j. We were just going to make sure to override the version of Log4j that was in the containers, which was pretty easy to do in the CI/CD system. So that cut down on the amount of QA that we had to do. That cut down on the amount of work we had to do in cutting a release. So we were able to get those new binaries tested and released very quickly because the first time we tried to update the libraries, it broke. There was some weird interaction with JBoss that the JBoss libraries were using for something else where it broke. The system wouldn't start up. Thankfully, we were able to figure that out pretty quickly, but because we had all that monitoring in place, it was pretty easy to catch it. So yeah, so we've been using this now for about a year, and it works really well. So we're done, right? Not so much. I think it was Corey Quinn that said Kubernetes is the name of the god of money. So once we had the system up and running, one of the things that we've always wanted to be able to do, but technology and budget have always made it impossible, is run multiple instances. We're a public safety system. If the bad thing happens, we need to have a way to protect ourselves, to be able to stay up and running. As an example, one of the jurisdictions, recently enough, had a failure of their on-prem Active Directory Federation system. And because of that, they couldn't look. Dead battery.
The batteries.
All right. I guess because of that, there were already systems in place to be able to switch to manual management of some of these things, but they couldn't actually turn those Check, check.
Yep.
Hello, hello, hello. Okay, cool. Put that in there. So, I don't care if they're encrypted. 6 ways from Sunday, secrets don't belong in Git. And so we had to figure out how we were going to handle our secrets. So let's talk about secrets. We needed to externalize our secrets somehow in order for GitOps to work. We were not going to store secrets in Git. Why shouldn't you ever store your secrets in Git, even if they're encrypted? Git is specifically designed to be easily copied. It is decentralized. I can clone a repo from GitHub, push it to GitLab, and you as the owner on GitHub have now lost complete control of that repo. You don't know where it's been, you don't know who it's been around, you don't know who its friends are. So, whereas with secrets, you want to make sure, not necessarily that no one has access to it, because that's unreasonable, but you want to know who's seen it. Kelsey Hightower did a demo to the SIG-Auth a couple of years ago of Vault's integration with Kubernetes. And he said, you know, the really important thing, and I'm paraphrasing here about this, isn't so much that Vault is protecting the secrets, it's that Vault knows everybody who's accessing these secrets. And that's the same type of thing we're going for. And so, if that's what you're going for, Git is a terrible place to put it. Also, you know, this kind of ties back to John's conversation earlier about key management. We are terrible at managing anything that's secret in this industry, keys especially. So now all of those secrets are managed by a key. Who has access to that key? What happens if you need to rotate it? Now you gotta go re-encrypt all the secrets. It's if you can't use a vault of some kind, I get it, but and it seems like a good idea, but once you start using it, dive into it, it doesn't work well. So we weren't going to do it. Also, I find that most people overemphasize what a secret vault is supposed to do. You know, if you use a secret vault to lock down the secret, it's kind of diametrically opposed to automation. You know, if you do it even when you do it really well, it doesn't work. And the other problem with it is that, wow. I don't know if that's me talking or it's catching a microphone.
I think when you turn towards the speaker, it picks it up.
Oh, good catch, good catch. So I can put this back here then. So, one thing that drives me nuts about Kubernetes is that the secret API, if things were if I ruled the world, secrets API would be a proxy API, where you can store things in etcd, where you can store things in a vault. And it would be transparent. Unfortunately, that's not the way the secrets API works, and it never will. And so the problem is that we've written a lot of software, we run a lot of software, it makes assumptions that there are secret objects, not necessarily stuff that's mounted to a pod, and kind of this quasi-cloud native approach. And so we want something that just creates secrets for us securely. And so this blog post does a great job of looking at the threat vectoring around secrets. I would highly recommend taking a look at. He does a much better job of explaining than I ever will. But the point is that we wanted secrets. We didn't care that it was an etcd. You know, the cloud provider wasn't going to be able to see it. Nobody was going to be able to make a dump of the data. We just wanted something that was going to synchronize secrets into our etcd. So we ended up going with the CSI secret store driver because it's got this capability. The kind of interesting proviso about that is before it will create a secret, it first has to be mounted to a container. So we ended up creating in every namespace that ran secrets a deployment of the pause container that would mount the secret, which would then force CSI to generate the secret object. So that way we're not using up main resources, one less thing to patch, etc. So we knew how we wanted to do it. The next step was how do we move from an existing cluster that has secret objects into a, excuse me, into this vault. So we ended up writing a script. That's the great thing about APIs. We wrote a script that we could point it at any secret object, and it would generate the correct CSI objects. It would generate the correct objects in a vault, and it would generate the correct deployment. And so once we did that, we had working with one namespace. We had working with all the namespaces pretty quickly. So it took us about a week to migrate dev. It took us about an hour to migrate production. So scripting, non-manual. So finally, we start looking at GitOps, and we learned some interesting lessons. One, eventual consistency is a lie. We tell ourselves that eventual consistency is real, but it isn't. If you've ever run a Helm chart and something failed, and run it again, and run it again, and keep running it until things catch up. Our software is basically a monolith. It's not a microservice. And so monoliths in general have this idea of state and sequence. And Kubernetes tries to avoid that. So we needed something that gave us a little bit of power there, or a little bit of sequencing. We're deploying a combination of Helm charts and static manifests. And we ended up going with environment-specific repos. I originally had this idea that we would have a mono repo. We'd have one repo. Everything would be a Helm chart, and we would do different values files for each environment. Problem is that our development environment is actually far more complex than our production environment. We have 22 jurisdictions. They don't have their own dev. We have applications that don't have their own dev. We reproduce all of this in our environment so that we can test our stuff before it goes live. So we, in fact, have 4 to 5 times more stuff in our dev environment than we do in our production environment. So having a mono repo just wasn't going to work. So we ended up having 2 separate environmental repos, one for dev, one for prod. And so we ended up going with Argo CD. I love Argo CD. I like GUIs. I think GUIs are a good thing. And so Argo CD's got a great GUI. And so I also really like the app of apps pattern. And so what that means is you define one application manually inside of your cluster that points off to Git that has all your other application objects in it. So you define that one app, it goes, loads all the other apps in, which then triggers Argo CD to do its thing. So it's a kind of a meta approach to it. It works really well. All right, so now we know how we're going to do GitOps. How are we going to actually pull it off? The big issue we had to run into is how do I move an existing cluster that was built painstakingly with YAML into GitOps? There aren't a lot of great tools for it. There's a kube control plugin that's called getAll that literally gets everything. Endpoints, replica sets, all the intermediate objects that you just don't think about when you run a cluster. We didn't want any of those things. We just wanted the important stuff, deployments, stateful sets, etc. So we needed something that was going to skip those intermediate object types. The other issue we had was trying to figure out, cleaning out just all of the metadata that gets pushed into an object. For instance, you might have a 6-line pod that has 75 lines in the managed by annotation in the metadata. We didn't want any of that stuff. We didn't want UIDs. We didn't want replica numbers, any of that stuff. So we needed something to clean it out. I couldn't find it. So I wrote it. And that's the beautiful thing, again, about Kubernetes is you can you can use reflection, basically. You can look at the APIs and figure out what's there. So wrote this tool. It is in by no ways a command line utility. It's written in Java, which I know is terrible for command line utilities, but we're going to use it for another project inside of Open Unison, so I wanted to write it in Java instead of Go. Yeah, it worked great. So what I was able to do is I was able to point this tool at a namespace in my production cluster. That generated all the manifests. Clean out some of the manifests I didn't need, clean up some of that stuff. Put it into Git. Set up the application in Argo. Let it sync. See what broke. So it wasn't quite automatic, but instead of having to rebuild, when we originally did the Kubernetes setup, I had to rebuild the cluster once, and I didn't have a tool like this. And the parts that I had to rebuild, it would take me days to get a namespace rebuilt. This went from days down to, I don't think any of the namespaces took me more than an hour, to be honest. And so that made the migration much easier, was automating that. So some of the challenges for GitOps. CI/CD. So that original CI/CD picture I showed you, we're still doing. But now what's challenging is instead of making a call to an API server to update a deployment, we now have to patch a deployment inside of a Git repo. So that's challenging for a few reasons. One, the CI/CD systems, I'll assume you're working with one Git repo. So if you've got a different Git repo, the CI/CD gets triggered by your application code's Git repo. You then have to go and update an operations repo. And so now you actually have to set up Git yourself. You have to have a key. You have to call the Git command. You got to make sure stuff doesn't overlap. So that was a fun challenge. Monitoring. The prompt stack is not very extensible. It's a bit of a pain. So what we decided to end up doing was we wrote a script that I'm sure will eventually bite us in the rear, but it would merge our changes in and then push it into Git. That's working pretty well. Argo CD has this thing called waves. I know Flux actually has state and sequence. Argo doesn't. Argo has this concept of waves where you say, okay, I'm going to run these manifests first, wait for them to be finished and deployed, then run these manifests, then run these manifests. So Open Unison, I think we needed to use about 4 waves. And that was just trial and error, trying to get the different pieces to work together. And then the last step is synchronizing Argo CD application objects in order. Because like I said, there are different parts of, we run multiple instances of Open Unison. Some of the Open Unisons are for provisioning, some of them are for SSO, some of them are reverse proxy, and there's a sequence in the way they need to start. And Argo CD doesn't support that natively, so we had to script that in. So this is how you can get in contact with me if you want to learn more about Open Unison. I'm also going to be over at the table. We've got a great demo of Open Unison with vCluster, multi-tenancy, if you want to learn about NCRNet. And thank you, and I'll ask any questions.
Are you using any of the other Argo products, rollback, events?
Not right now. Argo rollouts is kind of intriguing to me, the way that replaces deployments. That's one I would definitely be interested in, but because we're small, we only run 2 replicas of each container, it really isn't super worth it to us, but it's definitely intriguing. It's one that I would like. I've also thought about switching some of our manual script tooling over to maybe Argo workflows. But again, that's a little bit lower priority. Thank you.